first thing I want to look at today is this idea of regions in the plane. And all regions in the plane is drawing inequations or inequalities. Most of the time you think of that with number lines, but that's because most inequations have one pronumeral. And all regions in the plane are as inequations where there's two pronumerals. No difference really. So if you need to draw a region in the plane, the first thing we do is we want to draw the boundary. So the same as with the linear inequation or quadratic inequation or any other type, we wanted to find those critical points and then work out, are we between the points or on the outside? It's exactly the same idea, but now we're talking about a region rather than sides of the points. So we're going to need to know the curve. Now, how do we draw that curve? Well, it all depends on whether it's a less than or equal to or a less than and so on. So the way we indicate with boundaries, we dot it if we're saying, hey, this boundary is not included. That, by the way, explains why we dot asymptotes. I mean, you might not have thought about that before. Why do we dot the asymptote? Because what we're saying is, hey, this boundary, the thing that's approaching, is not actually part of the curve. Okay? If it is included, then we'd have a solid line. Now, the point of intersection is key, because we need to indicate, is the point of intersection included or not? Now, when two solids line meet, not an issue. Okay? But if one of those boundary lines is dotted, we need to circle the point of intersection to indicate, hey, it's not included. Because remember, the point of intersection is only included if both boundaries are included. Okay, and then we work out our region by testing points. Let's do a very simple one, a linear one. Y is less than x plus 3, so I'll draw it in dotted. There's the line y equals x plus 3. It breaks up the number plane into two sections. I'll always go for 0, 0, unless of course it's not in the domain, because it's such an easy point to check. And it's all right. 0 is less than 3. Yes, it is. So we shade that side of the graph. Circle x squared plus y squared. In this case, it'll be a solid line. We know it's a circle. And once again, it breaks it up into two sections. But in this case, are we inside the circle or outside the circle? Well, if I'm unsure, let's test naught, naught. Let's see, naught is greater than or equal to 9. No, it's not. So we're outside the circle. This is always an interesting one. Y is less than or equal to 4 minus x squared. So we know it's our semicircle, which I'm going to dot in this case. Now I can test the point naught, naught, and we'll see, oh yes, naught, naught is included. Whoop, there we go. Yes, it works, but that's not the answer. Okay? Because what happens underneath? That's what happens underneath. Notice a couple of things here. I've done something wrong, by the way. What have I done wrong? What should I have done? We should have circled the point of intersection. Look, I've got a solid line meeting a dotted line. And so that x-intercept question is it included or not included? Go back to the inequality. The point of intersection on the x-axis would be the point where x is 2, for instance, and y is 0. If I substituted that in, I would get 0 is less than 0, which is not true. It's equal to 0. So yes, I should have circled those points of intersection. However, it's solid underneath, because again, if you go back to the actual inequality, y is always negative. So any x value in the domain, and that's why we stop at negative 2 and 2, has to be in the domain of the function. But any x value in the domain must work underneath, because negative is always going to be less than the positive square root. Right, let's do one where we've got a couple. So I've got y is greater than or equal to x squared. That, of course, is our parabola. Now what I tend to do, rather than shade, I just sort of indicate with a little couple of crosses and that. Can't use naught, naught, so I'll use naught, 1. Basically, I need to pick a point I know where it is. So points on the axis are usually easier because we can sort of define, oh yeah, well that's where that point is. Now, what do we got? 0 is less than or equal to 1. Yes, it is. So that's telling me I'm on the inside. So you notice I've just, well, I might have exaggerated it a bit, but I've just marked some crosses on the inside to the parabola to go, okay, I'm inside the parabola. Not going to shade it yet. Then I'll do my line. There's 3x plus 4. Again, now I can use 0, 0. Question is, do we have to find the point of intersection or not? I suppose it completes the solution. So, I'll label the points of intersection. But let's test my inequation, I should say. 0, 0. 0, yes, it does work. So now I'm simply saying to myself, oh, well, where did I put the red crosses and the blue crosses? So I know I'm in that little section in the middle there. Okay.